Okay, problem 127. A city has streets laid out in a square grid with each block 135 meters long. So your distance may be different from mine, but the solution process is going to be the same. If you drive north 3 blocks, then west for 2 blocks, how far are you from your starting point? This is a vector problem involving displacement vectors, but you could probably just figure this out using your knowledge of basic geometry and the Pythagorean theorem. But let's say you're going to start here. So this would be your initial position. Then you're going to drive 3 blocks north. So this is what we would be thinking is this is a displacement vector. But I'm just going to call it D1. I'm going to kind of avoid, since we're actually dealing in the X dimension and the Y dimension, I'm going to avoid calling it delta X, but this is just D1 is that guy. And then you go west for 2 blocks. And the idea is, well, how far apart are you? I mean, how far are you from your starting point? And so that's going to be D2, some vector. So basically we want to add, we're thinking about adding 2 vectors together. So we already did the tip to tail method. And so really what we're asking is, well, how far? This essentially is D1 plus D2. Now, I think you can see the right triangle. And this is going to be, we're going to be doing this, well, once we get into vectors more seriously in chapters 3 and 4, you're going to do this all the time. So the magnitude of this, so I might write this as, so if we're interested in, so vector D1 plus this, the vector sum of D1 plus V2 is this vector. If I want to get just the distance, how far, then we're going to think about the absolute value. So that is one way of, this is when you're, this is right in, under these circumstances, this is the best way to think about magnitude. Okay, so basically what is it? It's a Pythagorean theorem, right? We're going to take this side squared plus that side squared and take the square root of all that. So it's going to be the square root of, and let's just go ahead and put the numbers in. Okay, so what's 3 times 135? I don't know, but we're going to square that, and then we're going to add 2 times 135. I can do that in my head. I think that's 270 meters. If I thought about it, I should be able to do the other one. And we're going to get the sum. You're going to get the sum. Okay, that's how you do that guy. Problem 1.28. A butterfly flies from the top of a tree in the center of the garden. And it comes to rest on the top of a red flower at the garden's edge. The tree is 6 meters taller than the flower, and the garden is 18 meters wide. This is an example of a problem of, if you don't draw a sketch of this, you're going to be frustrated, because you probably, good chance you won't get the exact answer right. You have a good sense of how to do it. So please draw diagrams, make sketches, because if you have something to sketch, you can kind of not fall in the trap. Because I fell in the trap. I started to say, oh, this is 18 meters. No, it's not 18 meters. The garden is 18 meters wide, and the tree is at the center. Mastering physics. Okay, so the actual displacement of the butterfly, we don't know the flight path. What we know is, where did it start and where did it end? And so its displacement vector is that guy. So I'm just kind of using capital D. And we want to know is determine the magnitude of the butterfly's displacement. So I want the magnitude of this guy. So we could think about breaking this vector. Again, just think about, given the information I have, we want to think about drawing a box mentally or literally on paper and say, okay, I can get the magnitude of vector D. Also, you could write that as just D. It's going to equal to, it's the Pythagorean theorem, right? Do you see the right triangle? So vector D is the hypotenuse of this right triangle. So do we know the difference in height between the tree and the flower? Yes, 6 meters. Do we know this distance from the center of the garden to the edge of the garden? Yes, because we drew a diagram and we did not get tricked and get frustrated. Because if you kept putting in 18 meters, you'd keep getting the wrong answer and you go, what am I doing wrong? What am I doing wrong? What you're doing wrong is you're not drawing a diagram. So we could call this side dx and this side is dy. We're not really worried about positive and negative because it's just how far is this is one side of your right triangle and how far is that. So we're not going to be putting in negative. We could, but when we square it, it doesn't matter. So basically, let's just get to the answer here. All right, so we got basically 9 meters squared plus 6 meters squared. Your numbers may be different. You calculate the answer. All right, draw diagrams. Problem 129. A garden has a circular path of radius 50 meters. Yours may be different. John starts at the easternmost point on this path, then walks counterclockwise around the path until he is at its southernmost point. I knew my coffee mug would come in handy. Okay, there's a circle. What is a radius? On these problems, make sure you know, does this say radius or diameter? So I know that the radius is 50 meters. So John starts at the easternmost point. This is east, north, south, west, and then he goes counterclockwise around until, nope, keep going, the southernmost point. Okay, what is the magnitude of John's displacement? Not distance traveled. Distance traveled technically would be 3/4 of the circumference of this circle. What we're going to want is this, his displacement vector, where he ended up here and he started here. And so a displacement vector is just a straight line from where he started to where he ended up. Again, for now, I'm just going to use capital D, vector D for displacement. So I want to know the magnitude. The magnitude. All right, so let's draw a box around our displacement vector. And the idea is, do we have enough information to figure out what the components are? Because we're going to get the magnitude of his vector. So we could either write that absolute value sign, or if you just write the variable without the vector hat. These are both ways of saying I want only the magnitude of this vector. Okay, so what we do is it's going to be the square root of the x component, the magnitude, squared, plus the y component of the magnitude, just the magnitude part squared. So just thinking about this as really as x and this as y, do I know the x component of this vector? Absolutely. It would be -50. Of course, I mean, I could put -50 in here, just we square it, the negative sign disappears, and the y component is -50. I'm not going to worry about the negative because when we square it, they go away. So basically, the magnitude of D is going to be the square root of the x component, magnitude, squared, plus the magnitude of the y component, squared. And then there you go. All right, what's the direction? Just go back to think about this is north, this is west, this is east, and this is south, and you figure out which way that's pointing.